So, Tuesday, during the snow day, I went through and I looked ahead to the final. I told you this story yesterday. I went through and I looked ahead to the final, and I said, do we need to do Cramer's rule? And the answer is no, we don't have to do Cramer's rule. And I looked ahead and I said, do we have to do solving a system of equation using matrices? And the answer is no, we don't have to solve a system of equation using matrices. Okay? However, we do have to do some matrix operations. So today we're going to do the 3 basic matrix operations. Tomorrow and part of Monday, we will be doing matrix multiplication, which is more complicated. That's why we're going to expand that over a couple of days. And then Monday at the end of class, I will show you how you could go about solving a system of equation using matrices. But we have to do those 3. We have to do adding and subtracting and scalar multiplication. That's today. Matrix multiplication. That's tomorrow. And determinants, which is the second half on Monday. Okay? Those 3 topics, so your next 3 class periods, have questions directly on the final. Okay? So there will be a matrix addition or subtraction problem on your final. There will be a matrix multiplication question on your final. There will be a determinant question on your final. Okay? So 3 of your 15 final questions come from the next 3 days. Okay? I'm telling you that so that you understand that this stuff you need to know. Okay? Because it will be directly on your final when we take your final in May. Okay? So, let's do it. First off, we got to talk about what is truly a matrix. Okay? Matrix is the singular, matrices is the plural. Okay? So, a matrix is a rectangular arrangement of numbers organized into something called rows and columns. Okay? So it's a rectangular arrangement, rows and columns. One thing that you need to know about matrices is when it's all said and done, everything about matrices is rows by columns. Okay? Rows by columns. Dimensions, multiplication, addresses, okay? All different things that have to do with rows by columns. Okay? Side note, we name matrices using capital letters. Okay? Lowercase letters we reserve for variables. Uppercase letters are names of matrices. Okay? And another side note, the individual numbers that make up a matrix, those individual terms or those individual numbers are called elements. Okay? So a matrix is made up of individual elements. So, there it is. This right here is matrix A. Okay? I know that it's matrix A because there's the capital letter that names it. Okay? So that is matrix A. Okay? Matrix A is a 2 by 3 matrix. That's its size, its dimensions, if you will. The dimensions of a matrix tell me how big it is. Okay? So there are 2 rows and 3 columns. 2 by 3. Rows by columns. Everything with matrices is rows by columns. Okay? So matrix A is made up of 6 elements. Okay? 3 is an element. -2, 4, 1, 0, -5 are all elements of them. Okay? Each element has its own specific address. Okay? So, for instance, the number 3 has a specific address. Just like I have a specific address here in Wausau, you have a specific address here in the greater Wausau area. Okay? 3 has an address of matrix A, row 1, column 1. So we write that as A sub 1, 1. Okay. -5 has its own distinct address. Okay. It's in matrix A, row 2, column 3. Now, communicating a matrix to somebody else, you need to do 2 things to make it easier on that person. Okay? Because if I were to tell you, and I didn't have it visually up on the board, and I was to tell you what matrix A was, it'd be very hard for you to figure out the size. Okay? Okay? Because I could say 3, -2, 4, 1, 0, -5, and you could write a 3-row by 2-column matrix. You could write a 1 by 6 matrix. Okay? You could write the 6 by 1 matrix. Okay? So you could write all those different kinds. So in order to get over that hump, the non-visual hump, the very first thing that you have to do when you're communicating a matrix is tell the person the size so that they know. Okay? The second thing that you have to do, and this is more of a courtesy than anything, but you pause after each row. So if I were reading to you matrix A without visually seeing it, I would first tell you matrix A is a 2 by 3 matrix. Then I would go and I would read left to right, top to bottom. 3, -2, 4, pause for effect. 1, 0, -5. So that as you're writing it down, you know it's kind of like, you guys are probably too young to remember typewriters. Okay? But the typewriter, when you were typing along, it would ding when you got to the end of the paper. And then it would reset itself. So it's kind of like 3, -2, 4, ding, because then you go to the next row, 1, 0, -5. Okay? So when you're communicating a matrix, size first, so that the person understands how big to make it, and then pause at the end of each row. So, the first operation that we are going to be dealing with today is I'm going to lump addition and subtraction together as one. Because basically addition and subtraction is the same. Okay? So, if I am going to add or subtract 2 matrices, the very first thing that I need to check is that they must have exactly the same dimensions. Okay? So the rows by columns of each one has to be identical. Now, you may be thinking to yourself, well, a 2 by 3 matrix is the same as a 3 by 2 matrix. And the answer to that is no, they're nowhere near close. Okay? Totally different sides of the spectrum. They they mean they have, yes, the same numbers in their dimensions, but if it's not 2 by 3 and 2 by 3, or 3 by 2 and 3 by 2, they are not the same and cannot be added together or subtracted. So looking at these two matrices, the dimensions of the left matrix is 2 by 2, because there are 2 rows and 2 columns. The dimensions of the right one is also 2 rows, 2 columns, so it's 2 by 2. So they have identical dimensions. Therefore, I can go on. If they didn't have identical dimensions, bless you, I would write down not possible. That's the answer if you cannot add them. Not possible, because the dimensions are not the same. Okay. Being that these are good to go, then what I do is I add or subtract the corresponding elements. Side note, I forgot to mention too, matrices have brackets for the sides. Okay? Don't just put straight lines on your sides. That means something totally different, and we'll find that out on Monday. Okay? So you make sure that it's bracketed sides. For you, because most of you are drawing on lined paper, okay, don't be afraid to make each row on its own separate line. Okay? Trying to scrunch it into, like, trying to fill 3 lines on one, might lose some. Okay? Give them some space. Okay? For me, I don't draw my brackets because I don't have line on the board. I put my brackets in last, just so you know. But they still will show up. Okay? So, if I'm going to add or subtract the corresponding elements, okay, that means that this 4 is going to be added to 2. This 0 is going to be added to 7. This -6 is going to be added to -1. 2 is going to be added to -5. And then now for me, I put my brackets in based on the sizing. Okay. So then to finish it off, now I would just simply, so 4 plus 2 is 6. 0 plus 7 is 7. -6 plus -1 is -7. 2 plus -5 is -3. And that is my result. Questions on that? I'd like to say that it gets harder, but it doesn't. Adding and subtracting, that's it. You now know everything that there is to know about adding and subtracting matrices. Okay? Right? There's not going to be the next slide it's going to be, oh, but then you do this. That's it. That's all that there is to adding and subtracting matrices. Okay? So, with that being said, oops, I went a little too far. Do that one for me. I am able to add and subtract these matrices. This is a 2 by 2. This is a 2 by 2. The dimensions are the same. I can do that. So then this becomes 3 minus negative 3, negative 5 minus 0, 10 minus negative 2, and negative 4 minus 4. So my result then is 3 minus negative 3 is 6. Negative 5 minus 0 is negative 5. 10 minus negative 2 is 12. Negative 4 minus 4 is negative 8. So we get the 2 by 2 matrix, 6, negative 5, 12, negative 8. Okay. Now, side note about both of these types of problems. I'll just do it here on this bottom one. Okay. We could have said, or this problem could have been, and you might see this in the future, hint, hint, tonight on your homework. I could have said that matrix A is 3, negative 5, 10, negative 4. And then I could have said that matrix B is negative 3, 0, negative 2, and 4. Okay? And then I could have said matrix C is something else. And matrix D is something else. Okay? This particular problem, example number 2, could have been written out A minus B. That. Okay? Would have been exactly the same thing. Matrix A minus matrix B. Okay? Up top, it would have just been, like matrix, I think they were different, weren't they? Yeah, so matrix C plus matrix D, or so on and so forth. Okay? So it means the exact same thing. You're doing the exact same thing. It just is a different way of writing it, because the book, teachers in general, instead of writing new matrices all the time, I can just write 4 or 5 matrices, put it at the top of the page, and then say, all right, now I want you to find A plus B. A minus B plus C. Okay? And then I don't have to keep rewriting the matrices all the time. So, okay, that's what that means. Another style of problem says this: find the necessary value of x and y to make this matrix equation be true. Well, I've got a 2 by 2 matrix plus a 2 by 2 matrix equals a 2 by 2 matrix. So all the dimensions are the same. Okay? So it is a legal matrix problem. Okay? Because the dimensions are the same. Okay? So then there's a couple of different options here that you could do. First off, you could combine the left side into one matrix. Okay? So you could say that this is negative 2 plus negative 3, 1 plus 6, x plus 7, and negative 5 plus 4. And then that simplifies to be negative 5, 7, x plus 7, and negative 1. And you can say that that equals negative 5, y, negative 2, negative 1. And then if you have two equal dimension matrices, and those dimensions are, wake up, okay? And then those dimensions are the same, then those corresponding elements need to be equal. Okay? So negative 5 has to equal negative 5. That works. Okay? 7 has to equal y. So y has to equal 7 in order for it to be true. X plus 7 has to equal negative 2. So x has to be negative 9. Negative 1 has to be negative 1. So the two answers that you're looking for are x equals negative 9 and y equals 7. Notice that this is not a systems of equations problem. So therefore, I don't have to put my answer in point form, because I'm not looking for the specific point in space where those two lines cross, because I don't have lines. I have matrices in this case. So I can just list them out like that. Okay? But I need to know which one is which. So you can't just say 7 and negative 9. You need to know which one's which. Okay? Okay? We'll get to another problem like that a little bit later on. But first, I want to introduce the next operation with matrices. Okay? And that's something called scalar multiplication. Okay? Scalar multiplication is where you are multiplying an entire matrix by a number. Okay? The easiest thing that I can relate this to is the distributive property. Okay? If I had 3 times the quantity x plus 2, I would distribute that 3 into all the parts inside the parentheses. If I had negative 2 times the quantity x squared plus 2x minus 4, I would distribute that negative 2 into all the parts inside the parentheses. Well, with matrices, I do that exact same thing. I'm going to distribute the negative 3 into all of the elements inside that particular matrix. So this would become negative 3 times 3, negative 3 times negative 2, negative 3 times 1, and negative 3 times negative 10. So that matrix becomes negative 9. It's a 2 by 2 matrix. The size doesn't change when you scalar multiply. Okay? So it's still a 2 by 2 matrix. Negative 9, positive 6. Negative 3, positive 30. Okay. Side note, if I said that matrix A was 3, negative 2, 1, negative 10, and the problem then here, this exact same problem, would have been negative 3 times A, or negative 3A would have been the problem. Okay? Again, it's just like the A plus B or A minus B problem that we just had before. Again, we could have said in the next, or we can do something that looks like this. Okay? We can scalarly multiply 1 matrix or both matrices, and then add or subtract them together. So try this problem now. Alright, so just to model it one more time, I'm not expecting you to show tons of work. However, you do have to show, so the first thing that you would have to show would be this multiplication of this 4 into that first matrix. Okay? So that would be 8, 12, negative 4, 20. Minus 6, negative 4, 1, 5. Minimally, you have to show that. Okay? That's the minimum that you need to show. Okay? Now, if you show, like, Logan, I'm going to use you as an example. You showed this next step where you did 8 minus 6 and 12 minus negative 4. That's fine. Okay? Some people can do that in their heads. Some people need that extra step. That's a you call. Okay? That's up to you if you want to do that. Okay? So 8 minus 6, 12 minus negative 4, negative 4 minus 1, 20 minus 5. So that green step, that one's optional. If you want to show it, great. More work, more understanding. Okay? Because you're writing it down and you're doing it. Creates more synapses into long-term memory, which makes it easier for you to recreate it come final. Okay? 2 by 2 matrix of 2, 16, negative 5, and 15 is your final answer. Blue step, yes. Green step, optional. Okay? In this particular problem.
What if they ever give you like a problem where it's like 3, like if they're not the same, like a 2 by 2, what do you just put like no solution or something?
Not possible.
No.
Yep. So if they had like a 2 by 2 and then a 2 by added to a 2 by 3, not possible because you can't add corresponding elements. Okay. Try that one. So that one, if I distribute in the 1/4, that's going to, so I'm going to take this 1/4, multiply it there, 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 and there. Excuse me. 8 times 1/4 is 2. Negative 12 times 1/4 is negative 3. 1/4 times 0 is 0. 1/4 times 4 is 1. Okay. Then on this one, I have to distribute in the 2. Oops, that should have been red. Red is my distributive color. So then that becomes negative 6, 14, 2, negative 4. Both are still 2 by 2 matrices, so both can still be added together. 2 plus negative 6. Actually, I don't need to scroll down. I can just do it over here. 2 plus negative 6 is negative 4. Negative 3 plus 14 is 11. 0 plus 2 is 2. 1 plus negative 4 is negative 3. So we get a 2 by 2 matrix, negative 4, 11, 2, negative 3. Questions on that one? Find me what x is, find me what y is. So if I combine the left side matrices, I would first multiply this entire matrix by 3/4. So 3/4 times -4 is -3. 3/4 times 0 is 0. 3/4 times 8 is 6. And 3/4 times y is y. Or excuse me, it's 3/4 y. Okay? Then I would have to add that still to 3, 9, -7, -4. And so the left side would then become -3 plus 3 is 0. 0 plus 9 is 9. 6 plus -7 is -1. And 3/4 y plus -4 is 3/4 y minus 4. And that has to equal x, 9, -1, and 5. 9 here is equal to 9. Yeah, I know that. -1 here is equal to -1. Yeah, I know that. X then is equal to 0. We'll do purple, red. And 3/4 y minus 4 is equal to 5. So that's 3/4 y is equal to 9. So that's multiply here by 4/3. 9 times 4 is 36, divided by 3 is 12. So y is equal to 12. Okay. One way. Another way is you can do this math. Because really you're only concerned here because you've got a 2x2 plus a 2x2 equals a 2x2. So you know the corresponding positions are all going to be equal. So since x is up here in row 1, column 1, I take 3/4 of -4 and I add that to 3, and that's got to be x. I take this plus that equals that. Okay? So I get -3 plus 3 equals x. 0 equals x. Okay? You don't have to necessarily combine the left side because you know that the elements are all the same. And then, what color haven't I used in a while? Pink doesn't show up. We'll use green. Okay? So then y times 3/4 plus -4 equals 5. Which is the exact same one that we had down here when we combined. So either way, both work, both have great work that can be shown at it. Okay? Here is your homework tonight. It is due tomorrow. It may look like a lot of problems, but there is not a lot of work involved with the problems. Okay? There's 12 problems. It maybe will take you 15 minutes. Okay? Have a great, grand, and wonderful Valentine's Day.